All right. So today's lesson is day 2, more with the zero product law. All right. So the zero product law's importance to mathematics can't be overstated. It finally shows us in certain situations that we can solve equations that are higher order polynomials, higher degree than just a linear. Of course, for it to work, we must have two conditions met. We must have the equation set equal to 0 because remember, why do we set the equation equal to 0? Well, we cross the x-axis when y equals 0. That's why we set it equal to 0. We must also be able to factor the expression. So let's take a look at these first couple of examples. So example number 1 is a quadratic function. A equals 1. So I'm looking for two numbers that multiply together to negative 35 that add to positive 2. Multiplied to negative 35 that add to positive 2. Well, those are 7 and negative 5. Remember, when a equals 1, the factors you use are the factors you choose. So my factors are x plus 7 times x minus 5 equals 0. That means that x plus 7 equals 0, or x minus 5 equals 0. Subtract 7 from the first equation. That means x equals negative 7. Add 5 to solve for x in the second equation. That means x also equals 5. So these are the two places that my parabola crosses the x-axis. Remember, very important, we learned that the root is the opposite sign of the factor. The root is the opposite sign of the factor. Okay, let's look at example B. For example B, a does not equal 1, so the first thing I'm going to do is see if I can find a GCF. And I do have a GCF. I can take a 3 out of everything. So when I factor out a 3, I actually have 3 times the quantity x squared minus 10x plus 16 equals 0. So when I factor this, I'm actually looking for two numbers that multiply to positive 16 that add up to a negative 10. Well, I know that 8 times 2 is 16. If I make them both negative, negative 8 and negative 2 is also 16, and their sum is 10, negative 10, sorry. So my factors are 3 times the quantity x minus 8 times the quantity x minus 2. This whole function equals 0, right? So if x minus 8 equals 0, well, then I know that if my factor is negative 8, I know that my root is positive 8. If x minus 2 equals 0, if my factor is negative, my root is positive. These are the two places where the parabola crosses the x-axis. Remember, these are not only the roots or the y-intercepts or the zeros, they're also the solutions. That's going to be really important when we start word problems. They are also the solutions. All right, for this next example, I know it looks a little crazy, but I want you to think of this as one term and one term, or like one polynomial plus another polynomial. So I hope that you can see that each one of those polynomials contain a factor of x minus 3. So I can take out x minus 3, right? It's contained in a parenthesis, but I can take it out of both factors. So when I pull out x minus 3, I'm left with x plus 1 plus 2x minus 7. Now, because these are plus, because they're being added, because all of the terms are being added, I don't have to group them in any parentheses. So let's see. I'm going to combine some like terms. X plus 2x. Let's see what that gives me. So I'm going to start with my x minus 3 times the quantity. X plus 2x is 3x. And 1 plus a negative 7 is a negative 6. And I'm going to set each one of my factors equal to 0. So if x minus 3 is my factor, then my root is positive 3. For the second equation, or the second expression, 3x minus 6 equals 0. If I add 6 to both sides, I have 3x equals positive 6. I need to divide both sides by 3. So 3x equals positive 6. When I divide both sides by 3, I find out that x equals 2. So my two solutions, the two places where I cross the x-axis, are at positive 2 and positive 3. All right, so let's remember why this is such a crucial skill in terms of a parabola. James graphed the quadratic y equals 3x squared plus x minus 10 using tables on his calculator. He found that the graph shown below, he found the graph shown below, and he can tell from his graph that the table that x equals negative 2 is one of the zeros. X equals negative 2 is one of the zeros. That's this one right here. Okay. But he couldn't tell what the other zero was because it's not exact. You see, it's circled. It's not exact. It's not exactly on a grid line. So what equation would allow us to solve for this? Well, remember, we take the quadratic function and we set y equal to 0. So we let this function equal 0. So the equation that we're going to use is 0 equals 3x squared plus x minus 10. So we know that x minus 2 is a 0. It says, does knowing that x equals negative 2 help you factor the trinomial? Well, it lets us know one of the factors. Remember, if the root is negative, then the factor came from a positive. So I know one of the factors is x plus 2. So how am I going to factor 3x squared plus x minus 10? Well, I'm going to use the slide and divide method. 3x squared plus x minus 10. I'm going to slide over. So I really have x squared plus x minus 30. And I'm looking for two numbers that allow me to get a negative 30 as a product and a sum of 1. Well, that sounds like x plus 6 times x minus 5. So those are the two factors, but remember, I still have to divide. I still have to do the divide. So x plus 6, I'm rewriting my factors, times x minus 5 equals 0. But I slid over, I multiplied by a 3. So I have to divide both of my factors by 3. So my first factor becomes x plus 2, which is exactly what we got from the solution of x equals negative 2, right? We knew that x plus 2 was one of our factors from this right here. But 5 does not divide nicely by 3. So we're going to remember, take this and put it in front of the x. So we take our denominator and move it to the front. So my other factor is 3x minus 5 equals 0. So we have to solve this equation using factoring. Well, I know that if my first factor, x plus 2 equals 0, I know that the root or the solution is negative 2. And we already know that because it's graphed. And it was solved for us in example B. We were told that actually in the very beginning of the reading. But I have to solve this. 3x minus 5 equals 0. Well, I'm going to add 5 to both sides first. So that gives me 3x plus 5. And now I want to divide both sides by 3. And when I divide both sides by 3, I find out that x equals 5 thirds. X equals 5 thirds. So this place right here that we didn't know is actually the fraction 5 thirds. It's the fraction 5 thirds. Or we could think of it as the mixed number 1 and 2 thirds. Okay, so it's the fraction 5 thirds, or it's the mixed number 1 and 2 thirds. All right, so we can even explore higher polynomials and their zeros on a very limited basis. So far, the best we have done is x squared, but polynomials that contain x cubed can also be analyzed. These are known as cubics. So consider the cubic function f of x equals x cubed minus 9x. So we want to find the zeros of this function algebraically by factoring. So the first thing that we want to do is look for a GCF. So f of x equals x cubed minus 9x. Well, I see that I can divide both of my terms by x. So the first thing I'm going to do is factor out an x, and that leaves me with x squared minus 9. And it just so happens that x squared minus 9 is a difference of two perfect squares. So I know that the difference of two perfect squares factors out to be the square root of the first term and the square root of the second term. And both of these get joined, one with a plus and one with a minus. So this function, f of x equals x cubed minus 9x, is actually the same thing as f of x equals x times the quantity x plus 3 times the quantity x minus 3. All right, so now we're going to use our calculator and we're going to sketch a graph of the function. So this is a cubic, and we've never sketched a cubic before. We're just going to kind of model it, but there are 3 things that we do know. We do know the places that our graph crosses the x-axis. So I'm going to number my x-axes by ones. So positive 1, 2, 3, 4, and it's already got a 5. Negative 1, 2, 3, 4, and 5. And I know that my graph crosses the x-axis when y equals 0. So remember, I want to set each one of these factors equal to 0. I want to set each one of these factors equal to 0. Well, if x plus 3 is 0, then I know x equals negative 3. Because remember, the root is opposite of the factor. And if x minus 3 equals 0, then the root is positive 3. And this first one, the factor of x that we pulled out at the very beginning, that just equals 0. X equals 0. So where am I crossing the x-axis? Well, I'm crossing the x-axis at negative 3. I'm crossing at 0. And I'm also crossing at positive 3. So my function is going to, when I put it into my calculator, my function looks something like this. Okay, it's just a sketch, doesn't have to be perfect. All right, so you'll study higher order polynomial functions in Math 2 and Math 3. So consider the quadratic function y equals x squared minus 8x plus 15. We need to find the zeros algebraically using factoring. So the first thing that we want to do is set our equation equal to 0. So 0 equals x squared minus 8x plus 15. And now we want to figure out what two numbers multiply together to give me a positive 15, that when I add them, I get a negative 8. Well, that looks like negative 5 and negative 3. So 0 equals the first factor, x minus 5, and the second factor, x minus 3. So if 0 equals x minus 5, then I know my root is positive 5. If 0 equals x minus 3, then I know my root is positive 3. So the two roots, the two solutions to this function are x equals 3 and x equals 5. It says write the quadratic function in vertex form. Well, we're not going to do vertex form, but we are going to write it in factored form. We are going to write it in factored form. Factored form is exactly what we've been doing. We've been finding the factors. So our quadratic function y equals x squared minus 8x plus 15. This is standard form. And when I want to put it in factored form, y equals my two factors, x minus 5 times the quantity x minus 3. This is factored form. All right, so what is true about the x-coordinate of the turning point compared to the zeros that you found in A? Well, we didn't find the x-coordinate of the turning point, but there is something special that you can do with your x-coordinates to find so there's something that you can do with your roots or your solutions to find the x-coordinate of the turning point. So my roots, my two roots are x equals positive 3 and x equals positive 5. So just for sake of not using a whole bunch of variables, I'm just going to call them root 1 and root 2. So there's this rule, this equation that says root 1 plus root 2 divided by 2 equals the axis of symmetry. What? How does that even make sense? Well, think about it. Remember that the axis of symmetry is exactly in the middle between the two roots. It's the average of the 2 points. It's the average of the distance between the 2 points. So if you add the 2 points together and divide by 2, you will find the x-coordinate of the axis of symmetry. So if I were to take 3 plus 5 and divide that by 2, I know that the equation to the axis of symmetry is x equals 4. This is the equation to the axis of symmetry. So 1, 2, 3, 4, 5. Well, I know that my axis of symmetry lives right here at x equals 4. I also know that my roots, my solutions, my x-intercepts are at positive 3 and 5. So the only thing I need to do is find the vertex. Well, I'm going to plug in x equals 4 into my equation. Plug it into the equation and solve for y. Well, y equals 4 squared minus 8 times 4 plus 15. Y equals 16 minus 32 plus 15. Y equals negative 1. So the vertex is actually the ordered pair. My vertex is the ordered pair for negative 1. Do we know where your graph crosses the y-axis? We sure do. We know that it crosses the y-axis at positive 15. So I'm going to say that this is 15, and I'm going to extend that on both sides. And now you have this beautiful 5-point parabola. Okay, let's look at exercise 5. This is our last example. So a quadratic function can be written in factored form. We know that. It says, which of the following would be the coordinate of the turning point? Well, we need to find the roots or the solutions. So if the factor is a positive 3, I know that the first root is negative 3. And if the second factor has a minus 7, I know that the opposite of minus 7 is positive 7. And we just learned that we can take the two roots and we can add them together and divide by 2 to find the x coordinate of the axis of symmetry. -3 plus 7 is 4, and 4 divided by 2 is 2. So the equation to the axis of symmetry is x equals 2. Alrighty, so that's it for today. That's our video for today. Your homework is the following 2 pages, questions 1 through 6. Questions 1 through 6. I know you have a shortened class today. I know that we have a shorter class today. So you can do A or B for question number 1, A or B. For question number 2, you can also do A or B. For question number 3, you can also do A or B. And the same with question number 4, A or B. When you get to number 5 on the back, I want you to do all. So you're going to solve by factoring. And then you're going to sketch a graph. Solve by factoring and sketch a graph. And then for this last one, you're also going to solve by factoring. You're going to sketch a graph, and then you're going to find the zeros. I'm going to skip this. You don't have to do this last part. So you're going to just do A and B. You're just going to do A and B. We will do this together on Monday. We will do this together on Monday. All right.